excited to teach you about applications today. So we are going to start applying vectors to real-world situations, such as modeling the path of an airplane. And when we are doing vector problems, there's a list of things that we have to know. So before we get started, we're going to go over some terms that are going to be familiar from yesterday, but some new things that we do need to be reminded of. So the first thing is velocity. Okay, so velocity is going to be modeled by a vector. Okay, and that's because velocity has a direction, and it's going to be the direction of motion. So wherever the airplane is flying, or if we have a boat where the boat is going, okay, that's going to be your direction of motion. Okay, now the magnitude is going to be the speed. We talked about that yesterday. The magnitude is the speed. The magnitude is the what?
The speed.
The speed. Okay, so when you're finding the magnitude, you're doing the a squared, the square root of a squared plus b squared, right? That's our magnitude equation. Okay, each vector is going to have a horizontal component and a vertical component. This is something that we did yesterday. So those can be modeled in vector form or in component form with I and j. So your vector form, remember we talked about this yesterday in our notes. We did the magnitude of v times the cosine of theta to find the horizontal component, and then the vertical component was the magnitude times your sine, which made sense because cosine is related to the x-axis and the sine is related to the y-axis. Now, when you simplify those components, they're just referred to as a and b. And then you can also write that in component form with I and j, okay, where a and b are the coefficients of I and j. Okay, so it's important to know that this is the horizontal component, and then the second part is going to be the vertical component. Okay, so to find the true velocity, which is something that we're going to do a lot of today, you can add the vectors that represent the velocity in still air and the velocity of the wind. So what this means is the true velocity is going to be equal to the velocity in still air plus the velocity of the wind. Now for different situations, we might have something different for the wind. So we are going to be doing a lot of airplanes today, but we're also, tomorrow we'll also talk about some boats and some swimmers. So instead of the wind, it would be the velocity of what?
Water.
Yeah, the water, the current, the ocean, whatever we have. Okay? So you can set up your vectors on the coordinate grid, and that's going to help you determine what values of theta are. Remember, to find theta, we do use the tangent of b over a. When you are finding theta, you are always going to start at the terminal side. And the terminal side is something that you did in Algebra 2. And we've also done it this year. Whenever you're finding theta, you're always starting at the terminal side, which in this case, if you're thinking in terms of direction, it's going to be the east side. All right, now, again I mentioned the magnitude. Okay, the magnitude is the true speed. When you are trying to find the true speed, you are actually going to do the magnitude of the true velocity vector. Okay, so the magnitude is the true speed. And then I said to find magnitude, which formula do you use? The square root of a squared plus b squared. Okay, and then I'm just going to add to this that that's where v is the true velocity vector. now the next question I ask you is, what is the difference between 30 degrees north of east and north 30 degrees east? And then I ask you to draw it. So if you can do that without me, I want you to go ahead and do so right now. Most of you have a straight edge on your desk. I gave you a compass. Since we're doing direction, I thought a compass would be appropriate. Because compass tells you directions. Yeah. Hey, does anybody not have a straight edge? Okay, so if you aren't sure where to start by drawing the northeast, southwest, okay? And these are not toys, so if you're not using them appropriately, I will take them away from you.
That includes Spain.
Like if I can win like a game with a toy.
No. Okay, so like I said, you're going to start by drawing the grid.
Whoa. Should we be way down there?
Well, I just had more room over here.
Okay. It looks like you're drawing it in like a...
Okay, so here I have my north, east, south, west. Okay, so if I'm going 30 degrees north of east, okay, which is what I'm doing first, 30 degrees north of east, okay, you are going to start north and then adjust 30 degrees east. Okay, so that's going to be 30 degrees above the east line, which you are going to estimate. Okay, so then this would be 30 degrees. Okay, and then the next one is north 30 degrees east. So if I have north 30 degrees east, this is a little bit different. So that starting with the north means I'm going to start here. Okay, so I am going to start north, and then I'm going to adjust it 30 degrees to the east. So now my 30-degree angle is going to be here. So this is north 30 degrees east, where this is 30 degrees. Now, when you're trying to find your theta value, like I said earlier, your theta value is always going to start at the terminal side, which is the east. Okay, so if you're trying to find theta that goes from your terminal side to the vector, for this one, your theta is going to be 30 degrees. Right? Now for this one, if we start east and go to the vector, this is where my theta is. What would my theta value be for the second one?
60.
Good. Okay? And that's because each quadrant is 90 degrees. Okay? So your theta value is going to be 60. Now, there's more than one way that you can write this as a bearing. So 30 degrees north of east, you could also write this as north 60 degrees east, right? Because you could start north and then adjust 60 degrees east. You could start east and go 30 degrees north, okay? And you could also say 30 degrees east of north. Okay, so all of those would be the same as 30 degrees north of east.
60 degrees east of north.
Oh, yeah, thank you. Yes. Thank you. Yes, so So 60 degrees east of north. So if you start, if it's east of north, you would start north and then adjust. Thank you. Okay, and then same thing for this one. So I want you to take a second now and I want you to write another way you could say north 30 degrees east. Well, what's another way you could say?
That way.
30 degrees. 60 degrees.
30 degrees what? Yeah, so this was north 30 degrees east, and I could also say it's 30 degrees east of north, right? Okay, I could also say it is, if you know this is 60, right? This would be 60 degrees north of east. Or you could say east 60 degrees north. Okay, so any one of those would be fine. Okay, now we are going to start our first story problem. So we have an airplane that is flying in the direction 15 degrees north of east. Okay, and that is at 550 miles an hour. So that's for the airplane. So you have an airplane, you have the direction, and you have the speed. Now you also have a wind. Okay, and the wind is blowing in the direction 15 degrees south of east. And that is going to be at 45 miles an hour. What we have to do is find the component form of the velocity of the airplane and the wind. Okay, so the first thing you want to do is draw a visual representation. Okay, all of your practice problems are going to be story problems, so for every one you should have some kind of visual representation. When you're dealing with direction, it is important that you have a visual set up so you can see what direction the plane is heading. And then I'm going to draw my picture over on the right here since I have a little bit more space. Okay, and I'm going to help you set up your first drawing. Okay, so we are using the bearings northeast, southwest. And then we are going 15 degrees north of east. So if we're going north of east, okay, we would start east and then we would adjust to the north. Now I know that halfway is 45 degrees. Okay, so if I start halfway and then I can adjust to 30 and then I adjust to 15, it's not like it has to be exact, but it should be in the general vicinity. Now, the bigger the magnitude, the longer you want your vector to be. Okay, it doesn't have to be a perfect scale, but you should be able to tell which has the greater magnitude by looking at your drawing. Okay, so the first one I drew was the airplane. Okay, and the airplane was traveling at a speed of 550. Remember, the speed is the what of the vector? The magnitude. Okay, so 550 is the magnitude of this vector. Now, bless you, I'm going to draw the wind. So the wind is only going 45 miles an hour, so I am not going to make this vector as long as my airplane vector because the magnitude is not as great. Okay, so I'm going to just make a shorter vector here. degrees. This is also 15 degrees. And then this is my wind. So I'm labeling the magnitude as 45, and then I'm labeling the vector as my wind vector. And I made it watermelon colors for you, Eddie. Yay. Okay, so when we're finding the component form of the velocity of the airplane, we have to know what the theta value is. So remember that theta is always going to start on the terminal side. So from the terminal side to my vector, I have 15 degrees, so that's going to be my theta. And now I can use my horizontal component and then my vertical component. Okay, so the magnitude is 550, and that's going to be multiplied by the cosine of theta. Okay, so for the horizontal, it's your magnitude times the cosine. For your vertical, it's your magnitude times the sine. Okay, your calculators do need to be in degree mode. Okay, so if you don't have your calculator out, please get it out so you can do these with me. Okay, actively participating in your calculations is really going to help you remember when you have to do this by yourself. Okay, so make sure your mode is in degree. And then we're going to round this to the nearest hundredth. I just told you that if you don't do it yourself, it's going to be more difficult to remember the process. Okay, and then Jackson, what'd you get for the sine? Will you do that one for me? And we're going to round to the nearest hundredth, so it'll be 3.5. Good. Okay, so this is going to be your airplane vector. And now we're going to do our wind. So again, the first thing you want to do is identify what your theta value is. Okay, now I know from here to here is 15 degrees, but it has to be negative because it's going clockwise. Okay, so it's what you're used to doing with your terminal side. Okay, so your theta value is negative 15 degrees. Okay, and that's because of the position. Alright, so then your wind is going to be 45 cosine of negative 15 degrees, and then 45 sine of negative 15 degrees. Okay, so go ahead and calculate those. Okay, and Dylan, will you tell me what you get for the horizontal? And then Aiden, I'll have you tell me what we get for the vertical. Yep.
Oh, it's like physics
Stop.
all over again.
Shh, it's not appropriate.
Take your time.
Do you have it, JC?
Yeah, I do.
Oh, alright, go ahead.
What is it then?
For the cosine,
For the, yeah, horizontal.
43.5.
And round to the nearest hundredth for me.
Sorry, 47.
Yeah, thanks. Okay, good. Aiden, do you have the vertical?
Yeah, I have a negative 11.65.
Okay, good. Dylan, I'm gonna have you tell me the next calculation, okay? Alright, so for B, we are finding the actual speed, which is also known as the ground speed, and the direction of the airplane. I said hint, don't forget the wind. So the actual speed you will hear referred to as the true speed most of the time, but it is the same thing as the actual speed or ground speed. Okay? I feel like ground speed is used more in terminology when you're doing aeronautical things. So like you know, in movies they'll be like, "Oh, what's your ground speed?" So that's what they mean. Okay? That you're going to be your true speed. And your true speed is the magnitude of the resultant vector which is the airplane plus the wind. Okay, so you're finding the magnitude of the resultant vector of A plus W. So your resultant vector you are going to be adding together the horizontal component to the wind horizontal component. Okay, so you're doing 531.26 plus 43.47, and you should get 574.73. And then you're going to add 142.35 to negative 11.65, and you will get 130.70. Correct? Is that what you guys got? Okay, so now we are going to find the magnitude. Yep, so the magnitude is the true speed. Okay, so we are going to do the magnitude of the vector A plus W. So when we do the magnitude, we're going to do 574.73 squared plus 130.70 squared. Okay, go ahead and calculate that. Okay, yep, so Dylan, tell me what you got for your actual speed.
589.4.
Yep, and we are rounding to the nearest hundred, so that, yep, it'll be the 40, and yeah, 589.40 miles per hour. Okay, so that's going to be your unit. Okay, is in miles per hour. Now what we're going to do is find the direction. Right, now I'm going to draw another picture. So you guys are going to do it with me. Because I want you to understand where this is coming from. Okay, so I'm going to start the picture the same way that we did this one. I'm just going to be adding to it. Oh, sorry. Instead of Y, I'm just going to put north. Okay, so remember we had the 550 at 15 degrees. And that was our airplane. Okay, and then we had the 45, which was our wind. So yesterday we talked about when you have two vectors, you can find the addition of those two vectors by finding what? What is it?
I know what you're talking about. I have no idea.
Well, what's it called?
The
We drew this ourselves. Yes, the diagonal of the
the
parallelogram formed by the two vectors. So remember that you can move the vector anywhere in the plane. So if we think of this airplane vector, trying to make them parallel. Okay, and our wind vector as a parallelogram. Sorry that looks bad there. Okay, then what we can draw is the resultant vector that goes right through the diagonal. Okay, so that is going to be the airplane plus the wind. That's my diagonal. So when it says that you're finding the direction of the airplane, what you're finding here is this value of theta. You guys with me? So the value of theta here is going to start east and then go up to the resultant vector. Okay, we already know that this theta value is 15. What we're trying to find is this value. Okay, so what we do is we use tangent. When we use tangent, basically what I'm going to do is take just this little part of the picture. Okay, this is your A plus W. And what we have is theta, and A plus W has the horizontal component and the vertical component. So the horizontal component was the 574.73 that we found in our vector. The vertical component is the 130.70. So this is why we use the tangent, because isn't the tangent the opposite over the adjacent?
Yes.
And see how that's the situation that we have here?
Yes.
So your tangent of theta, when you guys do this, you'll just be doing the B over the A. I just want you to understand why we can use the tangent. You're using the tangent because it's setting up the opposite over the adjacent here. Okay, so the tangent of theta, you're using your B value from your vector, which is 130.70 over 574.73. Okay? The reason why it's important to set up this picture is so you can physically see where the airplane should be going. Okay? Because it doesn't have to be going northeast. Okay? It can be in any of the quadrants. And as we practice this more, we will work on that. Okay, so I'm going to do the tangent inverse to find theta. Okay, now your theta value is going to start from the horizontal line. If you find theta in quadrants 1 or 4, it's going to be with the east line. If I happen to be in these two quadrants, then theta would be in relationship to the west line. But when you find theta, what did you guys get?
12.81.
Good. Okay, so it's 12.81 degrees. So we have to put bearings with that. So we have to put a direction to that, north, south, east, west. See how in the picture I can see exactly where it's going? I know it's going to be somewhere in the northeast, right? Because look at my vector. So one way that I could say this is 12.81 degrees north of east. Okay, you could also say east 12.81 degrees north. You could also subtract that from 90, and then you could do north, whatever the complementary angle is, east. Okay, what questions do you guys have for me on that? All right, let's start example 2. You can just say one of them. Yeah. So you can pick whichever one you're most comfortable with. Okay, for example 2. You have an airplane that is traveling north at 280 miles per hour. Should I stick with my watermelon colors or should I switch it up? Switch. I do. Pink and green are my favorite. Okay, so an airplane is traveling north at 280 miles an hour. And then I'll give this a different color. And then it has a 38-mile-an-hour crosswind that's flowing in the direction north 60 degrees east. What we have to find is the true velocity of the airplane as a vector expressed in component form and in terms of I and j. Then we're going to find the true speed. Okay, and then you can round any decimals to the hundredths place. Okay, so the first thing we're going to do is start with a picture. Always start with a picture. Okay, so we have the airplane that's traveling north. So if it's traveling north, it is just going to be straight up here. Okay, and then I'm going to label that as the 280. So that's the magnitude. And then this is the airplane. So I'm just going to label that with an A. Now, what we're going to have to do is we're going to have to find theta, right? If you're finding theta of the airplane, this theta value, right, you're starting at your terminal side and you're going straight north. What is your theta going to be in this situation? It's going to be 90, right? That's your airplane. Your theta is going to be 90 degrees. Okay, now when we do the 38-mile-an-hour crosswind, that's in the direction north 60 degrees east. So if it's north 60 degrees east, you're going to start going north, and then you're going to adjust 60 degrees to the east. Okay, and remember we don't want to make that one as long as the other one because of the difference in the magnitude. Okay, so that is 38. That is the wind. Okay, so when you're thinking of the theta for the wind, okay, if you know that this is 60 degrees from starting at the north bearing, what's your theta value going to be? Your theta value is going to be 30, okay, because this is theta. You start at the terminal side, and then you go to your vector. Okay, so if this is 60, your theta has to be 30. Do you guys have questions about that? Okay, so what we have to do is find the true velocity. Remember that the true velocity is equal to the velocity of the plane plus the velocity of the wind. Okay, so it's your airplane plus the wind. So in order to find the true velocity, I have to find the velocity of the plane and the velocity of the wind. Okay, the true velocity takes both of those into account. So the first thing I'll find is the airplane. So to find the velocity of the airplane, I'm going to use the magnitude 280 times the cosine of theta. So we already determined that theta for the airplane was 90. And we should already know what that is. What is the cosine at 90? 0. Okay, so if this is 0, 0 times 280 is just going to be 0. The sine at 90 is what? 1. So then I will just have 280. Okay, so this is the velocity of the plane. Now I'm going to find the velocity of the wind. So to calculate it, I'm going to use the magnitude times the cosine. We decided that this was 30. If you accidentally use 60, what you would see is your horizontal and vertical components would be flip-flopped. Okay, so if you noticed, oh, I got the right answers, but they were in the wrong spot, then you just took your wrong value of theta. Okay, so the sine of 30 we know is 1/2. This is root 3 over 2. Because you're going to be adding them together, you can go ahead and do the calculation as a decimal, so 32.91. And then again, remember this is 1/2, so that would just be 19. Okay, so then what we're going to do is find the true velocity. So the true velocity we often call v, the vector v. And we're going to add a and w together. A and w. They make good root beer, don't they? Okay, so if I'm adding 0 plus 32.91, I'm going to get 32.91. And then if I'm adding 280 to 19, I'm going to get 299. Okay, now we also have to write it in terms of I and j, so this is going to be 32.91i plus 299j. And then we also have to find the true speed. So remember, the true speed is the magnitude of the true velocity vector. And I keep writing down these hints for you so that you get more familiar and comfortable knowing that the true speed is the magnitude for the velocity vector. Okay, the true speed is going to be the magnitude. As you start going off, some things can be confusing because you have different velocities and then different speeds. So writing it out, I do feel helps, and then it's something that you can look back at if you're not sure how we got something. So for calculating the magnitude for v, we're going to do 32.91 squared plus 299 squared, and then we're going to take the square root of that. you just calculate it? Okay, yeah, Logan, will you tell me what you got?
348.1.
Good. Okay, so then your true speed is 300.81 miles per hour. Okay, nice job. You guys ready to tackle the last one? Okay, you really have learned everything that you would need to know to do this last one, so feel free to work ahead of me. Okay, so you have a jet that's flying through a wind, and that wind is blowing with a speed of 55 miles an hour in the direction north 30 degrees east. The jet has a speed of 765 miles an hour relative to the air, and the pilot is going to head in the direction north 45 degrees east. Okay, now there is a little picture here of the jet and then of the wind. I like to put them on the same one, so that's what I'm going to do. Okay, so even if the book does have a picture, I encourage you to write one out yourself. Okay, so you have the jet that's going 45 degrees. Now the 45 degrees is nice. Do you guys know why? No, tell us. We don't know.
I know why.
Why?
Because 45 degrees out of 90 degrees is just also 45 degrees. You get what I'm saying.
Yes, so if you hit with your theta, right? If this is 45 degrees, we know that theta is also going to be 45 degrees. So even if you forgot to calculate the theta, you would have the right one if you used your 45. Okay, so this is the jet.
I like their picture.
You would. Okay, and then we also have the wind, and the wind is going to be north 30 degrees east. So here's 45, so now we're going to have 30. So sometimes these can get messy as they run into each other.
And Miss Whipple, I also found another really cool thing about 45 degrees.
What?
When you take the cosine inside of it, it's going to be the same
It
thing.
is, and that's something we're going to talk about when we do our calculations. Okay, now the reason why I like to put my pictures together here is when I get down to the direction, I'm going to be drawing where that diagonal would be. Okay, so we'll talk about that in just a second. Hopefully see some cool things. So the first thing we want to do is express the velocity of the wind. So there is more than just the true velocity. There's the velocity of the wind, and then this says in both component and vector form. So one thing I don't really like about this textbook is I think they throw around component form for both I and J and your vector form. So in this case, they say component and vector form. By component form, they mean the I and the J. Now, for your test and quiz, if I want it in the form of I and J, I will specifically tell you, write the vector in terms of I and J. Okay, so that will be very clear. I don't feel like this is as clear, which is why I'm letting you know if it says component and vector form, it means it wants it in terms of I and J and as a vector. Okay? So your velocity of the wind is going to be the magnitude, which is 55, its speed. And then if this is 30 degrees, think about what your theta will be, okay? Because theta is going to start east and go up to your 30 degrees. So your theta value is going to be what? What's our theta value going to be? So if this is 30,
60 degrees.
thank you. Glad somebody was with me. Okay, so we know that the cosine of 60 is 1/2. So half of 55 is going to be 27.5. And this would be root 3 over 2. Okay, and we can just keep this as a decimal. We are going to add them together. So then we'd have 27.5i plus 47.63j. Okay, now we're going to do something similar, but for your jet. So the velocity of the jet relative to the air as a vector in both component and vector form. Okay, so component and vector form. So for our jet, our magnitude is 765. And then we're going to do the cosine of, we already talked about how the theta is going to be 45, because 90 minus 45 is 45. Okay, and then Yusuf mentioned that we know that the cosine and the sine of 45 degrees is special because why? They're going to be the same. So if you do 765 times the cosine of 45, shouldn't that be equal to 765 times the sine of 45? Yes, it should. Okay, so sometimes we might see the same answer and then we get concerned like we did something wrong. But if the cosines are the same and the magnitude is the same, those components should be the same. Bless you. Okay, so then we're going to write it in terms of I and j as well. All right, and then we are going to find the true velocity. So if we're going to find the true velocity, I put a little note that true velocity is always going to be a vector, and that's because it has direction. The true speed is a value expressed in miles per hour, and it has no direction. So therefore is not a vector. Okay, so when you're writing the true velocity, it is a vector. It has direction. When you find the speed, which is what we're going to have to do for this one, it says find the true speed and direction of the jet. This says find the true velocity of the jet. Okay, and this just says as a vector. So notice how we have two things with the jet. See how you have the velocity of the jet, and this is the true velocity of the jet. Okay, so your true velocity is formed by doing the jet plus the wind. Okay, so if you guys want to write out where this comes from, the 27.5 plus 540.94, you can do that. Okay, so when you're adding those together, you will get 568.44 and 588.57. And it just says to write it as a vector, so we only have to write it as a vector. Okay, we don't need to write it with I and J. Now it says to find the true speed. So remember, the true speed is the magnitude of the true velocity. Okay, so if I'm going to find the magnitude, whoops, bye-bye timer, then we're going to find the magnitude of the vector that I found in part C. So 568.44 squared plus 588.57 squared. Okay, and then you should get 818.25 miles per hour. And that is your true speed. Now we're going to do the direction. Okay, so when you're doing the direction, like I said, that's why I like to do the picture. That way I can visualize approximately what I should have. Because if I extend this and then I make the diagonal to the parallelogram, okay, I'm going to be somewhere in here. Correct? I'll put that in blue. So look and see where this is. This is the jet plus the wind. Okay? See how this does look like it's a little bit above my jet line? So that kind of gives me a frame of where my theta should be. Okay? So it's most likely going to be greater than 45 degrees. Now, it all depends on the accuracy of your picture. Okay, so the more accurate your picture is with the magnitudes, the more accurate your estimation is going to be. Okay, so remember, when you're finding the direction, you're taking that vector and you're using the tangent. Okay, so you have your horizontal component. Stop doing that, please. Okay, so then your tangent of theta is your b over a, which is your 588.57 over 568.44. Okay, so to do that, we're going to use the inverse tangent to find the angle. Okay, and when you round this, let's do this together. Okay, so you're going to do the tangent inverse of 588.57 divided by 568.44. Okay, so this is going to round up to 46.0. Okay, and then because, hey, can you guys be quiet? I'm finishing the video.
James and Zach White, please go to the counseling office. Lucy, James, and Zach White, please go to the counseling office.
Okay, so you can say 46 degrees north of east. And then I'm just going to give you a couple of equivalent directions you could have. Okay, and then you guys should already have your corrected homework on the back. I gave you this sheet to put your homework on. So for number 1 and 2, those are going to go off of your note sheets. And then 54, 58, 59, and 63. Okay, so you can put that right here. And you should have a diagram or drawing for every story problem. Okay, so 1 and 2 are going to be similar to your notes, and then this is going to be from your textbook.